Hi everybody, and my name is Tamar, and welcome to my session. Today we're going to talk about machine learning in Node.js, and it's going to be an introduction to machine learning and how to combine it in your Node.js code, mainly architecture-wise, and facing the problems that Node.js rises to machine learning implementations. So, before we're going to deep dive into the technical part, I have to introduce myself, part of the duty. So, my name is Tamar. I'm a software engineer. I manage large development teams. I'm a software architect, and currently I work in Palo Alto Networks. Palo Alto Networks is the largest cybersecurity company in the world. And I'm working a lot with Node.js for the last 4 years. My interest in Node.js has actually started when I founded my own startup. The application that we wrote was a social network for food lovers. Then I wrote my entire server in Node.js. And at that point, I really fell in love with the technology and started to really explore it and become an expert in that technology. And you can all just follow me on Twitter. That's my Twitter handle at the bottom of the screen in bold. Some other things about myself: I lately finished my maternity leave. The cute little thing in this side of the slide is 10 years old right now. I have 3 kids in total, and I'm also a professional violin player. I studied in the music academy once, and I also have a degree in computer science, of course. And I'm also a community leader in the JavaScript Israel community. We have 2 lines of meetup in Israel. I'm a technical community manager, so we have really cool technical stuff. If you happen to be around and in Israel, there's a meetup of JavaScript Israel, of course, you're all invited. So after getting done with the introduction, let's talk about what we can do with machine learning. And for that, I have prepared in advance a really small demo. So I would like us to classify some image. So what in this image below? Yeah, that's a panda bear, of course. But actually I have a server here behind the scene. I mean, the Angular client is not really the point here. I have a server behind the scene which I'm going to ask what's in this image. And yeah, my server is telling me, hey, that's a giant panda or a panda bear, or I don't know what is the last word, but I don't know. I guess it took it from some kind of a panda species. But yeah, it got really cool predictions. Let's move on. So what is this? That's a rabbit. Yeah, but when I'm asking my server what it is, it tells me that's an hare. An hare, it's actually a female rabbit. And that's interesting because it's recognizing it not as a rabbit, but as a female rabbit, which is something I can do. So it's very cool. Now that is really straightforward ice cream. So I'm going to ask my server what it is. And it's going to tell me, hey, this is an ice cream. Cool. Let's go to image number 4, and that is a vase of flowers. And also my server identifies that correctly. A vase of flowers. Image number 5, a bunch of balloons. I'm asking my server, hey, what it is. It tells me this is a balloon. It actually really, I don't know, smart or something like that. So that example is kind of cool because I'm going to ask my server what it is. So that is a butterfly, but my server is identifying the exact species of the butterfly, because that word here, sorry, I had to invest more in my CSS. But that's like the butterfly species, okay? That is cool. Last thing is when I'm going to ask my server what it is, it tell me, yeah, that's a valley. And last image is, well, those are cookies, but when I'm going to ask my server what it is, it would tell me that this picture was taken actually from a baker shop. I mean, so it actually like making more assumptions than what I'm told him to do. So that is really, really cool, and these are some of the implementations that we can do with machine learning. So what is machine learning exactly? Well, actually it has several building blocks. Okay, so the first building block is having a model, which the model is implementing an algorithm. In this session we are going to mainly use the algorithm as a black box. We're not going to write machine learning algorithm or train them, because this is something which can take months of courses. But we have a model. This model is implementing an algorithm, okay? And the next thing that you should do is to give your model a test data, okay? The model is studying your test data. You're giving him a data set, you're giving it a data set, and it studies the data set. But what it studies, it's trying to recognize patterns in your data, okay? So according to these patterns, the model is making some assumptions. And according to this, at the end, the model needs to be able to perform a task with no instructions, according to the patterns it saw in, the test data set. Some cool machine learning applications. I have here Spotify discovery list. I have, like in Amazon or other e-commerce, the product recommendations are based on machine learning. Email spam filters are also based on machine learning. Even when you're getting into YouTube, you're like logging into YouTube and see what YouTube recommend you to see. That's also machine learning. But before, I don't know, we can just see some implementations. I would like us to get into some fundamentals in order that all of us would speak in the same language. So we're going to do like a really, really, really quick course in machine learning. So the first thing that we're going to talk about is the model itself, and we need to, of course, well, these are actually the four phases that are needed to build a machine learning model. First of all, we're defining the model and which algorithm it's going to implement. And then we are fitting the model, meaning that we're going to select something that we want to predict. I would give the example of house prices. Let's say that I have a data set of house prices, and I would like to predict how much my house would cost, okay? So I need to predict it according to something. Let's say that I'm going to predict it according to the number of rooms the house has, the size of the house, the type of the house, whether that's a private house or an apartment. Let's say that another thing that I'm interested in is what is the distance of the house from the city center. So those are the features, okay, which I'm going to use, and every machine learning algorithm has a prediction target and features, okay? So predicting is just what it sounds like. We're giving, after the model saw patterns in the data according to the features that it needs to examine. So we're giving him new data, and then the model is predicting. For example, for house prices, the model is going to predict a price for a new house that it never seen before, according to the parameters that it needs to examine. And at the end, we have something which is called error evaluation. That means, let's say that the real price of the house is $100,000, but my model has predicted $150,000. Okay, there is an error over here of $50,000, and that's a lot. And we do some kind of an evaluation process in order to understand how accurate exactly is our model. Now let's see an example of a data set. So that is actually a data set which is famous, let's say, in in basic machine learning algorithm. That is a screenshot from a really big CSV of Melbourne house prices, which is used as like a data set for a lot of simple training machine learning algorithm. What do we have in this data set? You see, first of all, we have the price, and that is, mainly the most thing that everybody is trying to predict. An interesting thing that we have here: at which suburb this house is in, how many rooms this house has, what is the type of the house, what is the distance from the city center, who's selling the house. So that is like an image from a real data set called Melbourne housing. You can look at it online. And now let's try to focus on choosing on which model to train. So I am going to display to you a model called decision tree. Why decision tree? Decision tree is a very simple machine learning model. I would say it is the simplest that we have. Okay, I think it's really easier to understand because it is based on decision trees, which I hope that at least most of you had encountered decision tree in your development career. And it is the basic for more complicated machine learning algorithm, such as random forest, for example. But the basic of random forest, for example, is a simple decision tree. And we're going to just understand the fundamentals with this example of Melbourne house pricing with this 1 gig CSV. So what is a decision tree? Let's look at a really simple decision tree. I think it's very straightforward. I'm going to ask whether my house has more than 4 bedrooms. If the house has more than 4 bedrooms, then I would say, yeah, the price is above $150,000. And if the price is below, and if the house has less than 4 bedrooms, then I'm going to predict that the price is below $150,000. Of course, it's getting much complicated. So here is like a little bit more sophisticated decision tree with 2 levels. And so here I'm checking in the root, I'm checking whether my house have 4 bedrooms. And then in the second layer, I'm checking whether my house is like the size is smaller than 100 square feet or bigger than 100 square feet. So according to that, there are several leaves. So imagine my house like arriving to the root, and then just going down, and then it gets to like 1 leaf, and that's what my algorithm is going to return. So of course, this is like a really simple example. Imagine thousands of rules being created, a huge decision tree, which is classifying your data into a lot of groups. Every leaf here in the data set, every leaf in the decision tree would represent a group, okay? So what the algorithm is doing at the end is trying to understand to which group your house fit, and according to that, it returns the price. So that is decision tree. It's rule-based. Just imagine, I don't have enough place in my slide, but just imagine like a huge decision tree with a lot of layers and a lot of grouping. So the step 2 is we're gonna fit the prediction data. Okay, what does it mean? As we said, we have to take features. Okay, if we're predicting house price, then for example, I need to predict how much the houses cost according to the number of rooms the house has, let's say number of rooms, the type of the house, the distance from the city center. So those would be my features. And then I would select one column to predict. The column to predict is the prediction target, and that in most of the cases would be marked as Y. And we're going to predict the patterns. We're going to find patterns in the database of X features, and according to that, we are going to predict Y. So I would like to show you some code doing that. Okay, so let's see. Here, actually, I have the image classification demo. So I would just open I would just open the yeah, that's it. I would just open the demo that I have made in advance. So I want us to look at what we have here. First, that is an Express server. I hope that all of you as Node developers are familiar with Express library, Express library for writing servers. And well, this this is a really typical Express server, very simple, with only one route called predict. So after that, let's go to the model and let's look at the interesting part. By the way, the folder structure is like, I have this main file of the server, that's the model, which gives me like the modeled entity itself, and those are the controllers. I would try to make it bigger. Okay. Okay, so here we're starting to see some machine learning code. So first of all, I would like to talk about this this library called decision tree. I would like to say that first of all, in JavaScript and in Node, we don't have a lot of we don't have like the richness of libraries in machine learning is not that big. So I found that library. And well, that library was not maintained for 4 years, but it gave me like really surprising performance. Okay, so it was really able to load the decision tree. Yes, I'm sorry, to load the Melbourne house pricing very, very fast. So another thing that we have here is CSV to JSON. It's just gonna help me convert my CSV into a JSON array. So let's start to look at here. So first of all, yeah, I have this CSV here, by the way. It's not very interesting, just a CSV, very big one. And I'm just telling, I'm telling my parser of the CSV to parse specific columns as numbers. And here's my data set in that line. By the way, everybody is seeing the code, or I need to make it even more bigger? Or that is fine? Okay, so here's my data set. And okay, here I'm doing another thing. I'm filtering places where my prediction target, which is the price, is empty. Okay, so why am I doing that? So handling empty columns is a hard problem in machine learning, and we're not going to get into it right now. There are ways to solve it. I'm not going to get into it, but just, for the basics, I'm removing the empty lines where the prediction target is empty. Here, okay, I'm just going to tell my model that I'm going to predict price according to the features, and the feature is going to be room, distance, and type. And here I'm going to get a new instance of my model. At this constructor, surprisingly, the training is happening. Okay, so the training is happening here inside. So that's why this constructor is expensive. So my model is looking at the data and searching for patterns. And in predict, I'm giving it new data. Okay, so I would just take it up. And why do I have, oh, right. I have the image classification server just listening at the same port. So I would try to take it up again. Right now, cool, debugger attached. And I have here, last thing I would like to show you, I have here a small client that I wrote. It's not very, what it's doing is just sending some requests with express promise, but what's important here for you to see that here is how my test data looks like. I'm going to send this array one after another using promise all. And I would like to understand which prices my server is going to give me. Okay, I would just go out here. I think it has to be larger. Okay, and here I'm going to do node client.js. And for the first house, it get me about $1,600,000. For the second house, it gave me close to $1 million, and that is the prediction for the third house. Okay, so that's like the first machine learning code that we've done in Node. Nice. And let's continue. Now we're talking about error evaluation, okay? Evaluating errors. So what we're doing here, let's say that my testing data have 1,000 lines, okay? So, and let's say that for each of them, the absolute value of the error is like 50,000. What is an absolute value? Let's say that the house price is, let's say, $50,000, but my model has predicted $100,000. There's a $50,000 difference. So, and you know, it can be a negative integer or a negative double or something like that. So we're taking an absolute value in order to measure the error and dividing it in the number of test subjects. And then we are getting the error. We're going to look at some code which is doing that exactly. And that's my server. I would just open up a new one, which of course I wrote in advance to that. So that is going to be here. Okay, that's also working on the Melbourne house pricing. And okay, so here's the model again. We're doing here again, we're parsing the CSV, putting it in memory, removing the empty, price columns, and then we have the class name, then we have the features, then we have the new instance, and that's the predict. Okay, and another thing that our model is giving us, I'm not doing it myself. I could have write a code which does, calculate the error and summing everything and and divide it. But well, the decision tree is giving me that functionality out of the box because it's really important. So what it's doing is decision tree evaluate, and it needs to get an array of JavaScript JSON objects. Okay, in the controller here, I would have two functions. I would have predict. I'm requiring my model. I would have predict, and predict you've seen earlier, and I would have evaluate, and well, my client itself. So that is the test data, and here I would just put the test data. Whoever didn't see the test data, just looked like that. JSON array with objects, and I would just put the test data here under header. Okay, again, I'm using request promise, and I'm going to try to understand what my error is going to be. And if we're going to run that code, I don't know if that needs to be bigger, but if we're going to run that code, then you're going to see something interesting. Well, yeah, the error evaluation for this dataset is 0. I just re-engineered it to be like that, that my model would give like super accurate predictions. No, actually, I just chose my test data wisely. But yeah, this model is not so accurate, but what it did, so the real price of each one of them is like exactly the prediction, and that is why the error evaluation is 0. Okay, so after we've spoke about basic principles, let's talk about popular Node.js machine learning libraries. So, first library that I guess you have all heard about is TensorFlow. And TensorFlow, actually what it does, most of the algorithms are working with matrices and vectors. Okay, So it looks for patterns in matrices and vectors. The next three libraries are neural networks libraries with neural network algorithm. We have Brain.js, which is the most maintained and famous library out of these three neural networks. And Synaptic.js gave us some more advanced capabilities in neural networks. And the last one, Com.js, was written by Stanford. Now, let's go back to our image classification demo, which was written in TensorFlow. But before that, just TensorFlow itself. It's an open source. It has like a set of really nice models. You can train them yourselves. And what is also good about it, that you have a lot of models which were already trained. I mean, for example, for image classification, I'm not going to train the model myself. I'm not going to feed the model with data. I have a predefined model which I can use. And it is really cool. It has also like predefined models that you can use while taking a video in your computer camera and trying to, trying to look for stuff in the video image which is received. And you're just getting all of this out of the box, which is cool. So the base unit here is tensor, and every tensor has some several properties, like what is the rank of this tensor, for example. Just imagine like multidimensional arrays and a lot of matrices. That's at the end how everything looks like. So how we're doing image classification with TensorFlow and Node.js. So I would just go back to the image classification server that we have seen in the beginning, that was so wisely detected what's in a lot of images. And let's look at the TensorFlow here, code here. Okay, so what do we have here? That is again really simple Express server written in Node. Okay, it has one line of code which is called classify. Okay, and that route that it has with classify, well, here it would just that's a server that is just getting an image name, looking it in the file system itself, and then doing classify. That is not the interesting part of the code. Let's look at the interesting part and how we're working with TensorFlow and Node. So first, according to the tutorial, you have to take two libraries. You have to require TensorFlow, and we have to require TensorFlow Node. Okay, so both of them are needed. So TensorFlow itself is just needed as a global variable, but TensorFlow Node gives you other nice capabilities of well, converting, let's say, JPEG images straight to tensors themselves, which is cool. You don't have to do it in your own. By the way, when I wrote the demo at the beginning, I just converted the image itself into a tensor array, which was like 100 lines of code, and then I was just like, oh, wait a minute, tensor TF node is giving me that functionality. I don't need to do that. That makes my code really short. So what we're doing here, well, first of all, okay, another thing, we are using that library. That library MobileNet is also a TensorFlow model, and that is the model which is doing the image classification, and it is already trained. Okay, so that is the model itself, and I saw a lot of implementation of it in client side and server side, and it's very easy to use. What you do need to do is just to load it, because it has to, like, get all the trained data patterns from some file that it is saving in the file system, and after you have finished loading it, then that is a classify itself. And after reading the file synchronously, I know I can read it asynchronously, and that's very important, but I'm just doing the code JPEG. I mean, my 100 line of codes were summarized into one line of the code JPEG, and then we're doing classify. And if I'm going to take up this, wait, okay, the server is up, and here I also have a client which just sends a lot of stuff. So if I'm going to run the client that I have, is well, just getting me like the panda image and the rabbit that we've seen. It's getting me the predictions. So after we've seen some code in TensorFlow, really simple code in TensorFlow, let's go to code in Brain.js, which is a library that gives us neural networks algorithm. What is Brain.js in a nutshell? Well, it uses GPU acceleration. What is GPU acceleration? GPU acceleration is like combining the GPU graphical unit with a CPU unit, just like really high level explanation, and that makes that gives us better performance. It is really fast and easy to learn. It's implementing neural networks. What is neural networks? This is a set of algorithms which are modeled after the human brain, and they're at the end recognizing patterns. Okay, that's what our algorithm, our machine learning algorithms are doing, recognizing patterns. What is a neuron? So the neuron, the real neuron, the biological neuron, is a unit in our nerve system. Okay, and that's like the main unit in our nerve system. Sorry, my microphone is falling down. Give me a second. Wait. Okay, I hope it will be fine now. So a neuron is the main unit in our nerve system, okay, which what a neuron is doing is just imagine like in our brain there are like a really big network of neurons, and each one of them is sending a signal to the other one, okay, and when a neuron gets a signal, gets an input, it produces an output. Okay, and this output is getting as a signal to the other neurons in our nerve system. So sorry, we are using artificial neurons, okay? We're not using real brain nerve system neurons. What is an artificial neuron? Actually, an artificial neuron is just a mathematical function, okay? And this mathematical function is getting an input and produce an output, okay? There's a lot of mathematical functions that the neurons are using, but just imagine a net of artificial, artificial objects, and each one of them implements a mathematical function, okay? At the end, what's happened if we have this image of a starfish, then let's say that this neuron is just transferring. Here I have blue, here I have 5 arms and stuff, so it's getting to the end of the network, and that's how it is actually can allocate patterns. A small demo in Brain.js that I have to you. Something else that I would like to say is that you can see that combining the machine learning algorithms, is can be quite easy, because at the end, after you understand the fundamentals, it's just like it's a black box that you can use in order to do cool stuff. So what I'm going to do here is I have the Brain.js library here, and I'm going to try to understand whether this sentence was tweeted by Donald Trump or not. Okay, so how we're gonna do that? So I have here several sentences, and if it was tweeted by Donald Trump, I am giving it it's going to receive that output, and if it was not tweeted by Donald Trump, it's going to return to me fake Trump. Okay, for example, I'm not a human and I don't speak English. That was tweeted by Donald Trump at some point. And if I drop soap on the ground, is the ground is cleanest or is the soap dirty? That was not tweeted by Donald Trump. Okay, so what my algorithm is doing. So first of all, of course, we are requiring the Brain.js algorithm. Sorry, the library. We need to require it. And I have here a variable of train net. And okay, just executing the neural network constructor. Here I have process training data. Well, what's process training data is doing? What I'm doing here, I'm just doing encoding to each character that I have. And according to the encoding, we are going to detect patterns in the sentence itself. Okay, so here I'm going to do train net to function, and that's like the finished training. And here is the function which gives it a new input, and according to the new input, I'm going to give us the result, whether that was actually tweeted by Donald Trump or not. And let's just open it and see whether it's working. It would be working. So the phrase that we're examining here is, when you're waiting for a waiter, aren't you the waiter? And that was not tweeted by Donald Trump. But after talking about all of this, I would like to talk to you about another problem that we have. I want you to pay attention to something which is interesting. Have you noticed that the train and the execute doesn't have async await or promises in their code, or callbacks? Have you noticed that? No. Okay, so here we are getting to the next problem that we had with working with machine learning in Node. So yeah, did you notice that the algorithm was CPU intensive and synchronous? Okay, so right now I'm going to ask you whether JavaScript is the go-to programming language for machine learning. And the answer is, let's say it's maybe. I would say it's maybe closer to no, but I would say maybe, because we have several issues that we need to adjust here. Okay, so what are the main problems? So first of all, the machine learning algorithms are CPU intensive. Okay, and most of them are synchronous. I mean, whoever wrote them does not really understand the JavaScript internals. Okay, except TensorFlow, which is the which is like the light. But beside of it, they are CPU intensive and they are synchronous. The other thing that we have a lot of like matrices manipulations, and this is not like array management is not really efficient in JavaScript in total. And the last thing that I want to say is that the richness of library is not compared to, let's say, Python. Okay, but I want us to get into the CPU intensive problem. And having said that, let's talk a little about Node.js architecture in a nutshell. So what's happening when a new request is coming to our server? Well, when the new request is coming, a callback is being registered into the event loop, and then the set of callback of those requests is getting into the event loop queue itself. So we have an event loop which is running on single thread with one process, and then we have a worker thread pool with a constant amount of threads. So what the event loop is doing is offloading I/O operations and also CPU intensive operations to the worker thread pools. Why it is doing that? Because the node is working in a pattern called non-blocking I/O. Okay? If you're working with other languages such Java or Python or stuff like that, these are working as blocking I/O. And it makes sense because if I am, for example, doing a database query, my thread is blocked and waiting for the results. And it makes sense because usually I want to do something with that result. Okay, but here the event loop itself, because it's using callback and the mechanism is saying, okay, while I'm waiting for my database query, my event loop would, in the meanwhile, handle other work that is generated from other requests. So if you're doing a CPU-intensive operation or a synchronous operation inside the event loop, you're going to block it. That is not only for machine learning, but in general, if you're like doing read file sync, like I lazily did in my code samples, you're blocking the event loop. So, yeah, we already discussed that CPU-intensive operation will definitely block the event loop. But what is better than showing you actually what has happened and showing you some performance differences in order for you to believe me that I'm telling the truth? So let's again open something that I have prepared in advance. So this is a demo of CPU-intensive operations. Here I have like really two simple servers. I'm using the crypto library, and what I'm doing here is just hashing a password. Okay, so this express server is implementing one route, and here there is a password which I give, and I am using hash password. Hash password is just using the crypto API and is hashing it with a salt. Okay, and using this algorithm. You know, crypto algorithms are really CPU intensive as demand to do a lot of work, and that is asynchronous. Okay, that server code is exactly the same, but the difference here is that I would work with a callback, and I'm using the asynchronous crypto API with a promise here, and here, you know, the operation itself would be offloaded to the worker thread pool. Okay, so I would just go to the command line, and I would try to make it even bigger so everybody would be able to see. Okay, so let's start with that synchronous server. I'm taking it up. It is up. Okay, and now I can take this down as well, and I'm going to use a tool called AutoCannon. Okay, AutoCannon is a really nice library of NPM which is helping me in order to measure stress. I'm going to do here something very simple. Just generate a GET request with 10 concurrent connections parallelly. So let's hit enter and let's wait for that to end. Okay, so when we're measuring performance, just like give you the notion, we want to look at the average, okay, the average request, how much the average request is took, and then we're looking at the 97th percentile and the 99th percentile. Okay, so here 99th percentile, it means 99% of the requests were faster than this, and 1% of the requests were slower than this. And here we have approximately 2 seconds. That's the 15th percentile, and the average is here is about 1 second. That statistic is how many requests per second our server can handle, and that is on average it's close to 9 requests per second. Now I would like to take this server down, and I would like to take up the async crypto server. So here that works asynchronously, and let's do the test again, and let's see which results we're gonna get. Okay, let's start to compare it. On average here, when I'm working asynchronously, my server was able to handle 17 requests per second. When I'm working synchronously, my server was able to handle 9 requests per second. Almost double. Okay? Now, let's look at other measurements. When I'm working asynchronously, the average of the request is about 500 milliseconds, like half a second. When I'm working synchronously, the average request is 1 second. That's also double. Okay? So, doing CPU-intensive operations synchronously can really harm your server performance. Okay? So, try not to do that. Not related to machine learning, but also related to file reading and, I don't know, anything else that you want to do. How to deal with that? Okay? So we can fork another process. Okay, now that is interesting. Since Node 10.5, there is a new API called worker threads. Okay, and it can be used to solve that problem. It is running threads in Node, and each worker thread have its own Node instance, its own Node engine, but it is still one process and its own event loop. Each worker thread has its own event loop, so that's an API, a new API that it's really nice to consider. And the last thing that we will briefly talk about is scaling up with queues. Okay, so child process, I hope that all of you are familiar with child processes. Okay, so child process model, you're forking another process, and there is like a messaging system between the master process and the child process that helps them communicate. And in those cases, for example, for machine learning code and for the crypto code that I showed you, really prefer not to use it, and actually prefer is delegate. Just don't do it. Okay, why? Okay, when we're working with child processes, usually we map a process to a CPU. Okay, like our node instance is mapped to one of the CPU in our machine, so we map a process to a CPU. And usually the implementation of that is having, for example, a master process with, if I have 8 CPUs, 7 slave processes, and each one of them is mapped to a CPU, and it's working well. If I'm working in a server, okay, which is serving 100 requests per second, then imagine that I would have 100 new processes opened in 1 second, which would call my instance, my machine, to crash. Okay, so just that's something that you should not do. Working with worker threads, as I said, they're available in newer Node versions. It's experimental until version 12. Okay, in version 12 it has become not experimental. And yeah, it enables you to execute JavaScript in parallel. And as I said, one process, multiple thread, an event loop per each thread, and a JavaScript engine for each thread. It's a really nice API. The communication between worker threads are with messaging. And let's see how machine learning code is fitting into worker threads. So I'm not sure that we have the time to run it even. We'll just like show you the code itself, and you know, everything is going to be available on Twitter at the end, so you would be able to run it. Okay, okay, that's the machine learning model that we have seen with the on-prem sentences and encoding and everything. So that's like the main file that I have here. I'm requiring worker thread, and I need worker, main thread, and parent port. Okay, and what I'm doing a new worker. It's really resembles working with child processes. I'm giving it a path to a file. Okay, and I'm giving it worker data, and I'm trying to catch on message events, and that's how they're working. And worker itself, what it's doing, it's just executing the machine learning itself, and the training is done in an earlier phase. So that's how worker threads code is doing. It can be nice to solve this problem, but the best solution that we have is scaling up with queues. So if some of you are familiar with components like RabbitMQ, for example, or if you're working in GCP, Google PubSub, so what you're doing is, let's say that my server is going to send a message to a queue, and so I have consumers which are listening to messages, okay? And if I have an orchestration layer, like Kubernetes, for example, then I could say, hey, Kubernetes, map a consumer that I have to a CPU in the cloud, for example, and if I have a lot of messages in the queue, just add more consumers automatically, according to the lag. It's called the lag in the queue. So why is that the best way to do it? Because when you're working with worker threads, you are limited to the hardware that is currently that your instance has, okay? So you're limited to that. If you're working with RabbitMQ and Docker and Kubernetes, then you would be able to scale your consumers and do much more. Okay, so that is like for CPU intensive and for machine learning, I think that would be the best way to work. So I think I've took all of my time. Do you have any questions? Yeah.
So all this training was essentially done on CPUs, right? The time with neural networks, we want to train the models on using GPUs. Is that possible to be done with the libraries for Node as well?
Yeah, so for example, Brain.js is using GPU. You don't have to do anything in order for it to use GPU. It's built in. And most of the libraries have GPU built in. You have to check whether each library has GPU or not. Other questions? Yeah.
You use the last two strategies together?
Yeah. You can use them together. So for each consumer, use worker threads and Dockerize using Kubernetes and working with a queue. Yeah, it's possible. Any other questions? Okay, so thank you very much. That's my Twitter handle. If you wish to get the demos and the slides, they're going to be uploaded to there. I'm here, so if you have any questions, I'm available. Thank you very much, and go fast so you will be first in the queue for lunch. Like, there's a lot of food outside right now. And that's it. Bye.